Okay, it is about time. Hello everyone, I'm Harry Chen from the SolaX Power Technical Training Center. Today, I will share information about the new generation of the SolaX Power EV chargers. Following the release of the first generation charger, we received a virus of the valuable feedback regarding its appearance, functions, and price. As a result, we have designed a more compact, attractive, affordable, and powerful chargers to offer our customer better choice. So today's topic would be mainly about the SolaX EV Charger Generation 2, and we arms to empower our customer drive with the 100 pure green energy. And before we start the webinar today, I've noticed you something. If you have any questions during the process of the webinar, please do not be hesitant but to type your question in the question box, and my colleague will help me to answer these questions. When the training is finished, we will last for our webinars for another 10 minutes to answer the remaining questions. So please don't be worried, all the questions from you would be solved till the end of today. So let's start. Today we will cover three main sections. First, I will introduce our EV Charger Generation 2, including its types, compatible inverters, and the naming rules. This will help you understand which type of the EV charger best suits your needs. And the second, I will focus on the key features of the EV Charger Generation 2, with an emphasis on its new functions. I will also cover some of the basic features for those who are new to our product. Third, I will present the EV Charger Generation 2 solutions, using diagrams to provide you with the comprehensive understanding. And let's start. First, let's start with some basic information. Based on the needs of many residential scenarios, the SolaX EV Charger Generation 2 offers a new 4.2 kW model in addition to the previous generation. This means our chargers cover nearly all the power range available in the market for the AC chargers, providing various options for different applications. We also support both the socket Type 2 and the plug Type 2 chargers, allowing customers to choose between using a charging gun or a special bi-directional cable for charging their vehicles. Notable, the two new features highlighted in the yellow are key innovations of the EV Chargers Generation 2. The 1-3-phase switchover is a new function for 3-phase charger that reduces the minimum charging power from 4.2 kW to 1.4 kW. This enables the chargers to start operating earlier and reduce the waste of the green energy. Additionally, our current charger's hardware supports the AC V2G function, which means the vehicle to the grid. This means that our customer can use these energies to store in their vehicle battery to power loads in the certain scenario. For example, during the camping trips, customer can take the chargers along and use the vehicle battery to power device needs at the campsite. And let's go ahead. This slide presents a list of the inverters that are compatible with our EV charger. Our chargers are compatible with the most of the mainstream models we offer. I want to emphasize that even if the inverter model used by the customer is not listed or is from a different brand, we still provide a CT or meter solution that allow the EV charger to operate independently. Currently, compatibility testing is underway for the X3 Mega G2 and X3 Force with the EV charger, and I believe this will be complete soon. What's more, let's take a look at the product. This image shows the appearance of both the socket and the plug type EV chargers. We offer two different color options for customer, white and black. The image here displays the white version, which is our standard model. The evcharger Generation 2 design features a 3-layer structure consisting of the white top cover, a black middle frame, and the base at the bottom for the wall mounting. This design creates a more layered appearance, and the front top cover, compared to the previous rectangular design, now adopt a more beautiful placing round runway design. The overall front of the electrical vehicle chargers features a concave design. The black middle frame, including an LED light bar that lights up in different color according to the operating mode and status. Below the LED light bar is an RFID reader to facilitate card activations for the customer. Similar to the Generation 1 model, the right side of the charger is equipped with an emergency button for shutting down the EV chargers in case of an emergency. For the Type 2 socket version, a cable is needed to connect the EV charger to the vehicle. During the charging, the EV charger will automatically retract the cable to prevent the risk if someone attempts to unplug it. The Type 2 plug version comes with a built-in charging gun. The customer should ensure that the charging gun is inserted back into the EV charger after each use to prevent the damage to the device. So that's about the product view. And what's more, I'd like to introduce the naming rule. The most of EV chargers you encountered will only include the first 3 fields in their name. Let me explain each of these fields. First, the initial field indicates the phase information of the EV charger, indicate whether it is the single phase or 3-phase. The second field, HAC, is the series name for the SolaX second generation chargers, standing for the Hyper AC, and this helps to prevent any confusions for the customer who might mistakenly purchase the DC charger instead. The third field includes a number that represents the rated power of the EV charger, while the latter indicates the type of the plug or socket. Moving on to the fourth field, this represents the special versions of the charger. For instance, L indicates the charger is equipped with the LED screen, and the letter E indicate the charger is designed to meet the UK market's requirement for the PEM protection. Finally, the last field indicates the color of the device. If the color is white, this field will be left blank. If the color is black, it will be marked with the letter B. Okay, so let's keep the introductions for the key features. So the both two function, which is the 1-3-phase switchover and the AC V2G, is the most important two functions in today's introduction. So we will talk about it in detail later. Our EV charger is very intelligent, since it has 3 different kinds of work modes, and with the help of the functions of the dynamic load balance, the EV charger system will always keeping stable, and the breaker will never be break due to the help of the EV charger. And we can also use our SolaX app, which name is as the SolaX Cloud, to make the smart control and monitoring of the EV charger, since we can use our SolaX Cloud to make all the settings and the configuration for the EV charger. And the next features for the EV charger is the open connectivity, since our EV charger supports really a lot of communication protocol to make it very easy to be work with a third-party platform. It supports OCPP platform, Modbus and TCP and RTU platform, and it also have support the Open API protocol. And what's more, according to different kind of environment scenario, sometimes the Wi-Fi connections method for the generation 1 EV charger is not always be suitable. So for the generation 2, we add the LAN port and the 4G network method to the EV charger. So our customer can choose one of these three network methods according to their need. And what's more, our EV charger is also very user-friendly, since our customer can use the Amazon speakers to make the voice control of the EV charger, and the installation of the EV charger generation 2 is very easy due to it has a 3 layers design structure. And we also have 3 different kind of the activations modes, which are the RFID, NFC, and APP. And yes, it's also very important to talk about the safety of the EV charger. For the plug type EV charger, it have IP class the 65 and IK10 for the protection. And yes, this for the plug type. And for the socket type, it will be has a little bit different, since the IP protections is only IP54. So when customer choose the different types, it will be better to consider about the application environment to choose the one would be better to suit to the scenario. And the last features for our EV charger generation 2 is it can be applied in multiple scenarios. Since with the help with the data hub, which is the management device for our company, we can support up to 60 units in parallel in somewhere like a charging station. So it can means that our EV charger can meet the commercial and industrial needs. And we can also use our EV chargers to make the schedule, since we have the schedule setting for that. So that means we can use our EV charger to lower the household electricity cost. And since it has many communication protocol, so our EV charger is very easy to be used to integrate with the third-party platform. And yes, that's the brief conclusions of the features of the EV chargers, and some of the important things I will introduce them detailed following. So let's start by the charging mode. These 3 images illustrate the 3 operational modes of the EV charger: green mode, eco mode, and fast mode. The main purpose of the green mode is to charge the electrical vehicle with renewable energy as much as possible. The green mode consists of 2 sub-modes, the green 3 amp and the green 6 amp. However, it is important to note that the boost mode ultimately outputs a current of 6 amp or higher. The designed 3 amp and 6 amp represent the minimum surplus current required for the EV charger to operate. In green 3 amp mode, if the surplus current generated by the PV system is less than 3 amp, the EV charger will not start to charge. But if it's between 3 to 6 amp, it will purchase the remaining current from the grid and use the 6 amp to make the charge. And for example, if the surplus current now is the 4 amp, so the EV charger will draw 2 amp from the grid and finally charge the electrical vehicle at 6 amp. In green 6 amp mode, the smart EV charger will only start to charging when the surplus current generated reach 6 amp. So you can see in this diagram, when the current is less than 6 amp, it will not start to charge without drawing any electricity from the grid. It is worth mentioning that when the surplus current from the PV system exceeds the 6 amp, for example, is 8 amp, it will use this 8 amp to charge the vehicle. The green mode will utilize the entire surplus current for charging, ensuring no wastage of the renewable energy. The eco mode helped users charge their electrical vehicle with renewable charge energy as much as possible when maintaining efficiency above the set minimum. The electricity from the grid assists in maintaining the set current. For example, if the set current is 16 amp and the surplus current from the PV system is 10 amp, and the EV charger will purchase the remaining 6 amp from the grid and use the 60 amp to charge the car. And however, if the surplus current from the PV system is 18 amp, the EV charger will charge at 80 amp to avoid any wasting of the energy. And in the fast mode, that's the very easy to understand mode, the EV charger will output a maximum current regardless whether the electricity is from the inverter or the grid. This mode is typically used by the users who want to charge their electrical vehicle as quick as possible or in the areas where have huge gap between the peak and off-peak utility price. So let's go ahead with the one three-phase switch off function. This function is designed for the three-phase EV charger. In the green mode, the customer can choose to enable one three-phase switchover function. For other brand of the three-phase charger, the minimum current output current is 6 amp. However, for a three-phase EV charger, the minimum output power would be like 6 amp multiple with the 220 watts and multiple with 3, so it will be equal to 4.2 kilowatts. So that means when the power is less than 4.2 kilowatts, the EV charger will be unable to operate, result in the waste exceeds the PV energy. To address this, we designed this one three-phase switchover feature. The system will automatically detect the input power is above the 1.4 kilowatts or not, and will concentrate all the energy on a single phase at the output. This allows the EV charger to start operating earlier. As shown in these two diagrams, 6 here represent the charging time. The left diagram shows a system without a phase switchover, which can only operate when the PV input is higher than the 4.2 kilowatts. The right diagram shows a system with the phase switch off, which begin charging when the input power exceeds the 1.4 kilowatts, thereby extending the charging time. So that's the benefit for this function. And what's more, let's talk about the time boost function. And this function can be used both in the green mode and the eco mode. We can set a start time and end time to achieve the full powered operations of the EV charger during a specified period. These functions can help our customer to charge their electrical vehicle when the electricity prices are lower, and it can save money by scheduling charging during the off-peak hour. It also helps customers fulfill their charging needs as quick as possible while utilizing the grid and economical electricity. This diagram shows the SolaX AC V2G, and the V2G means that the vehicle to the grid solution. When the grid is disconnected, the customer can use the electrical vehicle chargers as a backup power source to continue to use the old EPS load, just like showing this picture. It's worth mentioning that in the inverter system, the EV charger needs to be connected to the EPS port to achieve this function. When the grid is functioning normally, the EV charger will operate according to the set parameters. If installed on the grid port, the AC V2G functions of the EV chargers cannot be used due to the anti-Iceland requirements. Our current AC V2G is already hardware ready. And once the software design is complete, this function will be officially realized. And the next functions I will introduce is about dynamic load balance. When the users activate the dynamic load balance function, they must know the mean grid capacity throughout the charging period, regardless of the operational mode. The total power consumption of the household will not surpass the mean grid capacity. To maintain this limit, the charging power would be dynamically adjusted in the real time based on the total household power consumption. In the setting, the users need to enable dynamic load balance and set a current value slightly lower than the limit of the main breakers. Using this diagram, for example, when the current value is set to 60 amp and the dynamic load balance the same as the main breaker, the EV charger will automatically adjust its maximum current value based on the current load's power usage. When set to the 60 amp, the load current value is 30 amp. The EV charger will use the 30 amp for charging. And if after some times the load's current value rises to 40 amp, and the EV charger will automatically reduce its working power to ensure the system operates normally and stably. In some countries, such as Germany, the local regulation required that the power difference between the phase in a three-phase grid would not exceed 4.6 kilowatts. Like this. Sorry for the wait. The customer using a three-phase grid with a single-phase EV charger risks violating this regulation. Therefore, we designed the dynamic phase power balance function, allowing our customer to set the power difference value according to the local requirement. When the working powers of the single-phase EV charger is too high, the system will automatically reduce the charging power to ensure the customer safety. It is worth mentioning that this function requires the EV charger to obtain the power from the grid side, which can be achieved by using inverter communication or three-phase CT. This is also one of the new functions of the EV charger. And our new version of the EV charger offers our customers three different kinds of the activation methods, which are the APP method, RFID card, and just use a smartphone with the NFC ability to make the activation. The customer can choose the method that suits their preference. And next, let's introduce the interoperability of the EV charger. The new version of the electrical vehicle chargers still come with the built-in Wi-Fi model, allowing the customer to easily connect the electrical vehicle chargers to a router for data interactions with the cloud platform. However, since many customers require the most stable and independent network connection for the commercial and industrial scenario, the new versions of the EV charger also support 4G internet and the Ethernet connection. This provides a convenience for the establishment of the charging station. In the commercial scenario, most customers prefer to use the third-party platform to make the management of their EV chargers. The EV chargers support OCPP, which means the Open Charge Point Protocol, as well as the Modbus TCP or RTU protocol. This allows the control rights to be given to the third-party platform to manage and rent out the EV chargers. Additionally, the EV chargers can be integrated into the virtual power platform system, which we also call it VPP, and can making our customer management more intelligent. Using this Monta platform as an example, when customers' EV chargers are idle, they can choose to link their EV chargers to Monta platform and rent them out. This allows them to earn some income. The Monta platform will display SolaX idle EV charger on the map and provide charging service to the electrical vehicle users. This means that our EV charger can also generate income for the residential customers and is very easily to be applicable to the commercial scenario. And the last part, the following part is about the communicate with the Amazon speaker. Since our EV charger support many different kind of the communication, so we can make the communication with the Amazon speaker with the EV charger. That means our users can also choose to control the EV charger generation via the voice commands using their Amazon speaker, make their life become more funny due to the technology. And it is the important part from today's topic. Since the installations for the generation 1 is not very easy since it has the all-in-one design. So for the generation 2, we have a 3-ladder design, and each part can be individually installed. So the customer just need to separately install the power and communication lines on the base and the middle frame respectively, and they just need to follow the installation guide to finish these 3-step installations within a very short time. So that will also help our customer to better easier to install that. And the most important things for a device must be the safety. Our EV chargers support IP65 waterproof and dustproof rating, and it also support IQ 110 impact resistance rating. For the leakage, we also have the leakage protection, and we also have the relay staking detection to make sure that our customer will not have any chance to worry about our quality. And according to the requirements of the control and monitoring, we have a SolaX cloud for our customers to make the control and monitoring of all our device, including the EV charger, and it has a special designs for the EV charger's interface. And if you are interested about this part, you can have a view of my EV charger generation 1 video. And at here, I think I introduced the more things in detail, and it is also a big topic to show everything about our SolaX cloud. So I will not talk too much at here, and but if you need, I will send you some things to help you better understand how to operate the SolaX cloud for the EV charger. Okay, so let's jump into the third section. I will introduce a series of the application scenario and solution prepared by SolaX for everyone. Firstly, the most common is the solution where the EV charger is connected to the inverter via communication cable. In this scenario, the EV charger functions as a normal load in the in the circuit. The inverter communicates the PV information to the EV chargers via an RS485 communication cable, as well as on-grid circuit information obtained from the meter or CT. With this information, the EV charger determines its current operating logic and status, especially under the eco mode and green mode operation. The parallel function is a function added by SolaX in response to the customer demand. In the home use scenario, to achieve the orderly charging of the two EV charger, we centrally manage the remaining compatibility of the PV system, and the remaining household electricity capacities are located to the EV chargers. This helps prevent chaotic charging that could cause the equipment fluctuations in the electricity consumption. The primary EV chargers communicate with the inverter to gather surplus PV information. Based on this information, as well as the operating status and modes of the both EV chargers and the household current limit value, the primary EV charger regulates the working current of the two EV chargers. For the small business scenario, our EV charger can support the operation of 20 units in parallel without the accidents of any other equipment. Additionally, other devices will be controlled by the primary EV charger. In small commercial scenario, the users can also use the data hub to parallel up to 60 EV chargers in all, with each stream support up to 20 units. This function enables centralized dynamic load balance management of the small charging sites via data hub. Data hub dynamically regulates the power of each EV charger based on their operational status and available capacity. This is achieved by configuring the charging station's power consumption capacity and collecting the real-time data from the meter's parallel board. Okay, so that's everything about today's webinar. And thank you for your attendance. I really want to see you on site, and in the future we will have the hands-on trainings in every country. So please also focus on our message in our social media, and you can also give us some feedback according this QR code. And you will have a chance to win a 15 euro or dollars Amazon voucher. So that's everything about today's webinar. I will help my colleague to answer the remaining question. Wish you have a good day. Bye everyone.